This is Lafas. I'm now working for Motorola as a software engineer manager. Every day we receive lots of bug reports from our customers, from our testing, and our engineers, our technical experts. They spend a lot of effort to triage for those bugs. The motivation here is that we are looking to build a service that works to triage for those bugs automatically for us. We would like to introduce DeepBug, a hybrid of CNN and RNN approach for software bugs triage. So, how do we manually triage a software bug? We look at title, the description of the bug, and get a quick idea for what issue it is and what's the behaviors. And most importantly, we will look into the logs, try to identify from which layer and for which component that the bug was happening. So the idea behind DeepBug is to mimic this process. We designed a hybrid architecture with convolution and recurrent networks running in parallel. As we can see here, the CNN path will take care of the log learning, and the RNN path will learn from the text sequences such as the bug and title and the description. Then at the end, those two flows will be aggregated as for the final output as a classifier. We have trained our model with both public datasets such as the Chrome and the Firefox project, and also we validate and further build our model with the industrial dataset and also our internal data set from the Jira system for bug reports. So each bug report comes with title, description, and logs, and the data label is the component. This means for the closed ticket bug report, the component means where the issue was finally fixed, and for the new ticket, this is the component we are trying to predict for. So we convert the data sets into JSON files and wrap up the bug title, description, and the component label with a JSON object. Log traces are processed in the same way, but with a separate JSON object. Then we clean the data, such as removing the tabs, URLs, because we believe those does not contain any effective information. So we can see that the title and the description are vectorized as 20 by 200 dimensional, and the log fragments are 20 by 200 by 5 dimensional matrix. So we have built our models with Keras framework, and the CM path was based on AlexNet, and the RM path we have compared the GRU model with the long short-term memory design, and it turns out that RM with GRU units reach a better performance. So here is a profile for the RM path, the model. The result we got is quite exciting. So we will validate with our internal data set and industry data set. DeepBug has achieved an accuracy of 86% for the top 20 software components classification. And here we also compared the accuracy from our SMEs. So you can see for most components, DeepBug is working very well, and for some component there's still a gap. Obviously the manual triage is more accurate, such as for these calling features. Some discussions here. So from our project, we believe that it is more promising to classify for software component instead of developer. There are lots of related works done in the industry and by researchers which take the developer as the target for classification. We suggest that there is no distinct connection in between the developer and the debug fixed by him, because he might be working on the domain or the component for a while, and then he will change it. Instead, our analysis suggests that it makes more sense to classify against the software component, especially for production. And based on this intuition, we have changed the dataset and labeled it for the software components, and we got a very exciting result. Another topic is that learning from log files. We have been seeing that a CNN model can learn well for the bug reports, especially for the log files. This might be because our software, in our case, it is based on the Angel stack, and the log prints are for each layers and for each component. So it's actually a structured information. So we can take a CNN network, just like image recognition. It works to abstract the features and at a high level to classify to which subcomponent the bug has happened. Dropout. We found that, interestingly, excessive dropout lead to that validation loss runs below the training loss, and you can resolve it by decreasing the key prop and or using less dropout layers. Future directions. So we plan to scale DeepBug for more components. Totally, we have more than 300 components for our software system. It can save us a lot of effort and reduce the cost. Of course, DeepBug can be further improved and tuned, especially in our case, the CM path is for the logs which comes with a structured data. It can be further improved to generalize well for more data sets for industry. We have been taking reference for many papers, but those two are the most important ones, especially for the one by Sensi. We have been borrowed some ideas and scripts for data pre-process for our case. Huge thanks to Paul, our mentor. He has been working closely with us, and he has provided very good advice such as for word vectoring and IM model tuning. And a huge thanks to Andrew and Ken for such a great cause. It is proved to be very powerful, for the deep learning technology, when you combine it with your own domain and push it to production. So that's for DeepBug. Thank you all.